So just give me 5 minutes. What I want to do is I want to unpack with you guys how to select a capacitor for a rectifier circuit. This also includes a half wave, a full wave, and whether you're doing a full wave with a center tap transformer or a diode bridge, it doesn't matter. It's the same formula. What we're doing is we're taking the formula, we're selecting the capacitor because of the period in the frequency and the output waveform and kind of the shape of it or what it looks like. And whatever circuit puts it like that, we don't care what the circuit is. We're just more focused on what the waveform looks like, its frequency and its period. What I'm going to do is I'm going to focus on frequency, and I think that's one thing that you really need to understand, and that the frequency changes depending on whether it's a half wave or a full wave. Really? Yeah, let's take a look. So what I'm going to do is I'm just going to unpack capacitor selection for a half wave and capacitor selection for a full wave. And again, whether it's a bridge rectifier or a center tap transformer, it doesn't matter. It's the exact same formula. Let's talk about frequency. So what's going on here is that I've got this waveform. I've rectified the waveform, and it's coming out like this. I've done it through a half wave rectification. When I have my half wave rectification, it looks like this. I'm only getting the top portion of this, and then these lower halves here, the negatives, just don't go through, and then I'm only getting this gap here. So I want to define what frequency is. In this case, it's really simple. The frequency is very, very based on, actually in all cases, the frequency is very based on the period. We get the frequency from the period. In this particular situation with a half wave, the frequency of the input waveform is the same as the frequency of the output waveform. So that would make sense. But let's find out why. So I wanted to find what a period is. A period is essentially how much time it takes for whatever the waveform is to repeat itself. So let's take a look at how much time it takes for this waveform to repeat itself. Both waveforms. So in this waveform here, this is one full sine wave, and then that repeats itself again and again and again. The time it takes to make this shape, which is one waveform, is called the period. Let's go down here. The period is for the pattern to repeat itself. So this pattern looks like this. I got this waveform here, and then I've got 0. And then I've got this waveform, and then I've got 0. That's the pattern. This waveform plus the 0, plus the flat line, is the pattern. So if I'm taking a look at how much time it takes to repeat itself, well, in this case, this is one full cycle here, and then that's one full cycle, and again, that's a full cycle, and that's a full cycle. And it just so happens that the period here is the same. So the period in this and the period of this are the same, therefore the frequency is the same. Now, I can take that and I can apply this frequency into my formula, which is going to tell me what the capacitor size is. Now, that formula, there are a couple different ways to do this. I'll just unpack this. Traditionally, we take a look at this formula here because it's actually RLC equals 10T. That's where it comes from. And then we just isolate for C. And we can see that C is 10T, where T is the period, divided by RL. Now in this case, I don't know what the period is because I'm only given 100 hertz, right? So I have to calculate the period. Okay, that's easy. I just calculate it here. So I'm going to do 1 over 100 hertz. And we know that it's 100 hertz because when we discussed it here, we can see that the time, the period is here is the same as the period here, so therefore the frequency is the same as the frequency. So I'm putting 100 hertz here, and then I'm getting 10 milliseconds, and then I'm dividing it by this, and I get 46.15 microfarads. Now, you've got a 47 microfarad in your kit. Everybody does. It's a very, very common capacitor. Maybe not everybody. But what I'm saying is it's around. It's easy to find. Any electronics store is going to have a bag of them available. So there you go. Use a 47. Always dial it up just a bit. I mean, you can go a lot more if you like as well, but not a lot more. I just want to focus on these formulas. Good. So what's going on? There's another way to do this. Option 2. This is a 2-step process. First, you have to calculate the period because the formula has the period, and then you have to put the period in. Well, you can just take this formula over here, and instead of putting a T, you can put 1 over F, which is CC. So I'm going to do 10 divided by the frequency times the resistance in brackets, and I'm going to put the frequency in and then the resistance, and I come up with the exact same value. So you're going to find a 47 microfarad, easy, no problem. These numbers worked out pretty good, but we're going to see that you're not always going to calculate a value that's nice and close to 47 microfarads. What do you do? We'll talk about that. what I want to do is I want you guys to really listen now, because I'm going to tell you about the frequency for a full wave rectified circuit and why it's twice the input frequency. Again, going back to what frequency is, and we define it by period. The period is to define the period, it's the repeating. It's how long it takes for the cycle or for the pattern to repeat itself. So because we're flipping this up to here, we're flipping this up to here, we're flipping all of these around, we get a full wave rectification, then the reason that, when that happens, pardon me, what we're doing is we're getting the pattern repeating itself actually twice as quickly. It's faster. So what's happening here is the period, the time is half as much. Therefore, the frequency is twice as much. Does it make sense? So if I take a look at this, I can say the frequency is going to be 1 divided by 0.5 of the period, or the frequency is 2 divided by the period. Or you can just simply just know that the period here is 5 milliseconds, so therefore the frequency is 200. However you want to look at it, the frequency is twice as much because the pattern repeats itself twice as quickly. Okay, good. So let's go down and just do the math here. Now, take a look at a circuit here. For us to do a full wave rectification, either we need a center tap or we need a diode bridge. Either or, it doesn't matter. Like I said earlier, we're focused on the output. We're focused on what this waveform, I don't care where the waveform came from. I'm trying to figure out a capacitor that will steady this out and give me that nice little ripple voltage coming out of here. I'm going to put a capacitor in there. It's going to give me this nice ripple voltage. Whatever circuit makes that doesn't matter. In this wave, in this particular example, I'm using a center tap, and my output is going to look just like that in full wave rectification. Again, it's the same thing over here. I got 60 hertz over here. Oh, it says 60. Pretend that says 100. You see how that says 100? See that? See that's 100? Yeah. Okay, let's move forward. Okay, so I got 100 hertz here, and I'm going to do 200. Because I know that it's repeating itself twice as much, so therefore the frequency is twice as much. So I'm going to 200 here, and again, I can do it this way, or I can do it this way, where I'm just going to put frequency right into the formula. I like to do it this way, saves me a step. And I'm going to get 23.26 microfarads. A 25 microfarad capacitor is a little bit more common than a 24 microfarad capacitor. So you'll have a 25 probably in your kit or somewhere around, or if you go to an electronics store, it's on the shelf. Now, if you actually want to get a 24, you can do that. You can go to Sale Electronics and they'll have it available. They might have it in the back. Or you can get it from DigiKey or any other electronics store. They will have it in stock. You just have to order it, or it may not be on the shelf. I get a lot of my stuff from DigiKey because they have like this huge list of everything. You just click on what you want and then order it, and it comes in and it delivers the next day. There's a delivery fee, but whatever. So there you go. So yeah, you can go get a 24 if you want, but put a 25 in there and that's fine. Do you know what? If you had a 47 in your kit and you didn't have a 25, put it in. It's going to be okay. But don't put a 470 in there. It's going to hold a charge for too long, and when you shut this off, it's going to then kind of run your load a little bit longer. So you don't want to go more than doubling it. It's probably too much. So 47 is just pushing it, but you'll find a 25 somewhere. And as far as the rest of this goes, I don't think there's anything else I need to talk about.